video, I'm going to show an example of how to use a matrix equation to solve a system of two unknowns. So I'm just going to start by writing it out as a matrix equation. So I'm going to write my coefficient equation, which is 2, 1, 5, negative 3. And then I'm going to write my variable equation, which is x and y. They're both the same variables. That's important here. And that's going to equal my constant matrix, or my solutions, 8 and negative 12. So just like a regular equation that I might have, so I don't know, something like 2x equals 8, in order to get the variable by itself, I'm going to undo or do the inverse of multiplying by 2. So the inverse of a matrix is the inverse of the matrix is something that we just looked at how to do. So we're going to take the inverse of this matrix, multiply it here, and then we'll do the same thing on the other side. Okay, so that means we need to find the inverse of this matrix. So we start to find the inverse by finding the determinant first. So we need the determinant of 2, 1, 5, negative 3. So I multiply my main diagonal, 2 times negative 3, which is negative 6. And then I subtract my anti-diagonal, and so the determinant of this is negative 11. So the inverse, you'll recall, is then 1 over the determinant, that scalar multiplied by some changed, a sort of rearranged matrix. So I take the main diagonal and I swap the order of the main diagonal. Negative 3 goes in the top corner and 2 comes down to the bottom. And then looking at the anti-diagonal, I take the negative, or the opposite of both of those. In this case, they're both positive, so they'll both end up negative. And then I just multiply through that scalar. I just distribute the scalar. So negative 1/11 times negative 3 is positive 3/11. Negative 1/11 times positive 5 is positive 5/11. And negative 1/11 times negative 1 is positive 1/11, and negative 1/11 times 2 is negative 2/11. So this is my inverse. So I do that on the side before I get started. So I'm going to take this and I'm going to multiply it by this matrix here to cancel it out, so I'm left with just my variable matrix. So 3/11 times 5, or I'm sorry, 3/11, 5/11, 1/11, and negative 2/11. That's my inverse matrix, and I'm going to multiply that by 2, 1, 5, negative 3. And that should leave us just an identity times this variable matrix. And on this side, I'm going to be really careful because I know that order is really important when I multiply matrices. So I'm going to make sure, notice how the inverse is to the left of the matrix here. So I'm going to do the same thing on this side. The inverse is going to be to the left of my solution matrix. So it's 3/11, 1/11, 5/11, and negative 2/11, and that is going to be multiplied by 8 and negative 12. Just going to clean up that negative 12 a little bit. Okay. So here, if I do this multiplication, that's 6/11 plus 5/11, which is 11/11. So that's looks a lot like 1. First row, second column is 3/11 minus 3/11, or 0. Second row, first column is 10/11 minus 10/11, or 0. And second row, second column is 5/11 plus 6/11ths, which is 11/11ths, or 1. So that is indeed the identity matrix. It's always just good to double check that that's true. But that means that's basically the equivalent here of it being canceled out to just being 1, right? That's canceled out. So now I've got just the variable matrix is equal to whatever my solution is going to be on this right-hand side. So 3/11ths times 8 is 24/11ths plus, that's a negative 12/11ths. And my second row, first column, is 40/11ths plus 24/11ths. So in other words, xy is equal to 12/11ths and 64/11ths. Okay. So my x value for my system is 12/11ths, and my y value for my system is 64/11ths. So using the matrix, the inverse matrix, I can solve this system with two not so friendly looking fractions that probably would have been a bit tedious to plug back in and solve for the other value. With the matrix equations, once we get comfortable with finding these inverses, it's actually a pretty straightforward approach. Okay, so you're going to do a couple of practice problems for homework and come to class ready to ask any questions. Thanks so much.